we have Suresh Neethirajan here with the talk titled Advancing Farmed Animal Welfare with AI, High-Throughput Phenotyping, Precision Monitoring, and Emission Reduction. So, Dr. Suresh Neethirajan is a professor and university research chair in digital livestock farming at Dalhousie University, Canada, cross-appointed between the Faculty of Agriculture and the Faculty of Computer Science. With a distinguished career at the intersection of artificial intelligence, precision livestock farming, and animal welfare, he leads pioneering research that integrates sensor technologies, machine learning, and computational technologies modeling to enhance the health, well-being, and sustainability of farmed animals. A globally recognized expert, Dr. Neethirajan has held faculty positions at Wageningen University and Research in the Netherlands and the University of Guelph, Canada, and has collaborated extensively with industry leaders, government agencies, and animal welfare organizations. Dr. Neethirajan serves as a mentor in BIPOC Graduate Mentoring Academy and WISE Atlantic, which is Women in Science and Engineering, and actively contributes to policy discussions on AI-driven agriculture, digital livestock monitoring, and climate-smart farming. His leadership in AI, ethics, embedded AI safety, and sustainable food production has earned him numerous awards and recognition as a thought leader shaping the future of precision agriculture. Beyond academia, Dr. Neethirajan is an advocate for responsible AI in animal farming, ensuring that technological advancements prioritize ethical considerations, animal welfare, and environmental stewardship.
Thank you so much. Thank you to the organizers for this wonderful opportunity. I looked at the list of speakers and quickly skimming through the audience. It's very broad and diverse. It's fantastic to bring together people from different walks of life, different expertise and domain to talk about this intersection. Kudos to the organizers. So when we look at artificial intelligence in animals, typically we look at from behavior, welfare, ethology, physiology perspective, but there is also other perspective in terms of the emissions. So when we look at emissions, right now, people have been using different kinds of sensor technologies, like wearable sensors, animal husbandry, housing-based sensing technologies to try to measure and map the emissions. But when we incorporate artificial intelligence along with satellite data, there is a much better precision and accuracy. One could look at how the emission profiles happens using remote sensing and AI-based, ML-based techniques. For example, in this study, we were looking at over 9,000 dairy farms across Canada, coast to coast, out of which we selected 1,300 farms and processors. So we were able to use different models from AI to look at, to come up with formula. For example, to be able to produce 1 liter or 1 kilogram of milk, how much of methane and how much of carbon dioxide is being emitted. When we quantify the data in terms of methane, carbon dioxide, and nitrous oxide using Sentinel-2, Sentinel-5P, and Landsat satellites, both from NASA as well as from European Space Agency, along with geotagged information, we can actually quantify, we can come up with a way to say, hey, you know what? There is a lot of variation in terms of these specific formula. That multifactorial formula is composed of course, the nutrition, the feed that the cow is consuming, but also the other factors in terms of wealth and hygiene protocol, behavior, etc. So we take both of these into account to be able to understand it. So in addition to that, we can also do predictive analysis. For example, we can run what-if scenarios if there is a specific supplement, such as help, or a specific nutrition component is lacking in terms of logistics. We can do a predictive modeling to see how much the emission is going to go higher or down using AI-enabled technique in terms of the emissions of the methane. IPCC guidelines and also the net zero 2050 in terms of bringing down the emissions, finding a carbon tax credit system in terms of balancing it out, call for a variety of techniques and strategies. And of course, AI really comes handy to be able to find a solution. But moving closely to the animal, I'll walk you through a couple of examples how AI is currently being used in the research as well as in the industry. Right now, there are a variety of sensor technologies we put on animals. For example, accelerometers, neck collar, some in the tail as well, to be able to continuously measure a variety of physiological biomedical signals. For example, breathing rate, the heart rate, in terms of what side of the body the cow lies, is right side or left side, how long she is walking, how long she is standing, etc. So lameness is a serious condition which affects almost about 30% of the cows, especially when she is pregnant. There is a bit of hunch that happens. If there is a certain injury in the legs, she finds it very difficult to walk. Also, it is associated to aging and other related factors. But farmers can now find the indicators of lameness only after it has come to a bit more serious stage, like level 3 or level 4, based on the body condition scoring. So what we have developed using a facial recognition biometric technology, along with the combination of accelerometer, is that we would be able to predict based on subtle cues and come up with a framework to measure what we call as iceberg indicators of lameness with the combination of computer vision along with sensor technology using a bunch of AI models. So we initially started with 6 cows and then scaled to about over 400 cows at multiple farms here in Nova Scotia, as well as in New Brunswick provinces of Atlantic Canada. So we can say that there is a much better possibility to predict and understand lameness even before it happens with the facial cues along with the accelerometers. When we look at the word emotions, I saw some topic related to sentience and etc. Of course, animals have emotions. For example, when we look at pigs, when we compare with the human evolution scale, swine or pig, a grown-up pig it's almost like a toddler, 4-year-old human child. That much level of intelligence a pig exhibits. We have a variety of ways to decode, understand the behavior using a number of experiments. For example, pigs can display empathy during their playful behavior. So when I utter the word emotion, the first letter of the word is E, motion. So which means that's energy in motion. There are a variety of energy comes into play here. For example, heat energy or thermal energy. So there is a lot of, when the animals breathe, inhalation, exhalation happens, the air that comes out of the nostrils or the muzzle, there is a bit of heat that changes that happens. Heat variation across the udder, vagina, and the reproductive organ is a bit different. Similarly, heat release in the eye region and the ear region is a bit different. So that's a thermal energy. The second energy in motion is the biochemical energy. When we draw blood samples, there are different markers associated to it: cortisol, lactate, neuroendocrine markers, etc. They are always there. For example, ketosis and metabolic disorders, beta hydroxybutyrate, and other chemicals, for example, non-stratified fatty acids, they are always present. But once they go over a certain threshold, then the animals become stressed. So there is a circulation of all of these chemical stress markers that changes. There is an energy in motion of time dependent, context dependent, of course. Another energy we could say is the bioelectrical signal. For example, the brain wave, when we put a little EEG on the head of the cow or a pig, we can actually measure how these signals varies. And so is the case with respiration rate and heart rate signals. So when we combine all of these different energy in motion, we can understand the actual mental makeup and look at how she's feeling, how the cow or pig or chicken. So again, when we look at chicken, they are smaller in size and shape, but the blink of an eye can tell a different story. By using high resolution cameras along with the AI-enabled algorithms, we can say how the eye blink, the variations in the heat associated to the eye in a chicken can be used as an indicator to find out about the mental makeup and the affective states of these animals. So here is an example we can see. We developed a biometric facial recognition system. We call this as a Diary DigiD. So it's basically a 30 key point annotation. So we collected data from 1,000 dairy cows across 15 different farms in Atlantic Canada. And then we annotated several thousands of images using a bunch of human annotators, and then used that to develop an AI-enabled algorithm. So the idea here is if there is a tightness in terms of the upper and lower clenching, squinting of the eyes, eye white that is in the black cornea as well as the eye white regioning, posture of the ears, whether it's symmetrical, asymmetrical, or the droopy. So all of these biometric facial different features help us to give us an indication of what is it that the cow is going through in terms of the emotions. So we, of course, we depend on some of the basic fundamental understanding of development of affective states from human systems, but we can't directly apply, then that would lead to anthropomorphism and objectification and so on and so forth, because we tend to look from the human eyes. So we started inducing positive emotions by providing enrichment materials, brushes, and other playful materials. Sometimes there is a cow-calf contact when the calf is being removed from the cow right after calving after a certain time. They exhibit specific stress through vocalizations and their body movement. So we did a set of series of experiments to induce this positive and a slightly negative environment we call as external stressors, and then started collecting a variety of data. So you can see here the Diary DigiD can easily classify using Gradcam model, whether the cow is dry, whether she is milking or mature milking, even the age, whether she is 2 years or less or about 2 years. Different ways of classifying is possible with the help of artificial intelligence with the AI-based techniques. So it has a lot of way. For example, we can right now, when intervention strategies are being made, even for feeding, we basically provide the signage or the order to the cow in a group level. There is really no individual precision feeding available for cows. For some pigs, yes, there is a possibility. So in the future, there is a possibility to better understand, okay, if she has certain nutrient supplement deficiency, can I be able to change that? Can I increase or decrease the feed? Can I change the different composition to meet her own individual needs? So those kind of decisions are possible based on the AI-based tools with the help of facial recognition. We also look at what we call as ascending or social network analysis. How does one cow talk to another cow? They tend to express their likes and dislikes through vocalizations, through vigorous licking phenomena. For example, if she's going to give calving, there is a birth process that's going to happen. she wants more space. So she demonstrates through specific body movement and vigorous licking, telling that, hey, give me more space. I don't want to be next to a bunch of cows. So the context really plays, and the whole facial future changes. So we have the ability to record. So it's the case with pigs as well. Again, it's a similar ear posture, the squinting of the eye, clenching, sometimes whining, what kind of squealing, what kind of vocalizations they make. So when we combine regular RGB camera video with the thermal camera heat signatures, with the acoustics, we can actually decode to more or less 13 different categories of their emotions or affective states, like relaxed, alert, neutral, aggression. So from a human perspective, from a form management perspective, we look at this into three: positive, neutral, and negative. But right now, most of the focus is on how do I avoid pain? From a production perspective, how do I increase the milk quantity and quality just by focusing on the pain? The ultimate goal of our research is, okay, let's shift from negative aspects to positive aspects. The animals are in the environment for maybe 3 years or 4 years, very short life. Is there something we could do with AI to enrich their quality of life? Can we be able to improve the awareness to the animal caretakers, to the people who are involved in this industry, to see can we be able to do a bit more compassionate farming? So that's the ultimate goal for tapping into the technology to bring more awareness about the affective states, emotions of these farmed animals. Again, this is just a basic study we did a couple of years ago. Just a demo to show if we go to a random farm and use the tool, the platform we have developed, the platform is able to identify the different emotions. So the key here is what we call as valence, the intensity of the emotions, because the emotions are time dependent. I cannot label a human being, he's an angry person. He or she, they or them, they may be angry for that particular moment, maybe a minute or 30 seconds, 20 seconds, and then they change their state, the emotional state, affective state to different. The same is the case with animals. So they express their frustration for some time if there is a delay in feeding, delay in water availability, but then they slowly shift to the other emotions. So we have to be very careful when we use artificial intelligence, because there is a lot of possibility of false positives, true negatives. An example I would give is if a mosquito or a fly, because lots of manure and other things that are commonly present in the bone. If a mosquito or a fly sit in the ear of the cow would normally flap her ears. So then the facial recognition system should not pick up signals and say frustration, disappointment. So that would lead to false positive or a different kind of output result. So we have to be really careful in deploying the technology from the context and making sure that the technology is just an assistant, supplement and complement, does not supersede the actual management of the farm with the human intelligence. There are different drawbacks also in terms of do animals have privacy? Do we really need to continuously 24 hours monitor, or do we allow her to have her own time? There are different normative questions from the ethics perspective, from the privacy perspective, one could keep on asking. We also develop few tools. For example, this is the tool we call this a track. Right now, there is a bigger emphasis on moving from cage system to enriched caging system, but we are also moving away from enriched caging system to free range. Let the birds walk around on their own. So we don't access to 24 hours water supply and feed. So how do we identify if you walk into a broiler floor, there are about 10,000 to 20,000 birds at a time. So even when we look at the cameras from single frame, we can see like 600, 700 birds, too crowded. So how do we identify? They also display certain aggression, certain social behavior. some group of birds try to emulate specific behavior. So the AI has the ability to study their smaller behavior. And irrespective of the group of birds, we could still identify, okay, this is Nina, this is Jane, this is Sally. Like that, we can identify individual birds and cater to the needs of those birds based on the identification and classification possibility with the help of artificial intelligence. So this is just a random application of the tool in an open form, just to demonstrate that the tool has the ability to pick aggression when one bird picks on another bird based on the movement and the activity indices. So the AI can go help the farmers to move from reactive to predictive and develop proactive approaches in enabling decision support for the farmers. But are we really using AI to make the animals look like data points? Or are we, does it help to really develop the respect for the birds, value the birds as a piece of life? That's the question we have to ask in terms of development, adoption, embracing of artificial intelligence technologies. Very quickly, this is another tool which AI enables based on the eye blinking, along with the combination of the thermal imaging. So, because there is also biochemical components associated to it, the frequency of the eye blink, how the head is being turned depending on a specific light condition, airflow, etc. So tiny smaller physiological behavioral cues can be quantified because the data comes in humongous, several terabytes of data. So AI helps to process this data in a real-time fashion using cloud processing to better understand the blink and thereby assess the health and welfare of these birds. We did a bit of study to understand the enrichment type. For example, especially for turkey, there are different kinds of enrichment. You can see that wooden slate, like a tunnel-like enrichment, some straw bales, some plastic positive enrichment to encourage positive behavior and improve the heel bone of these birds. So the technology also helps to when we combine computer vision with AI, we can assess, which or a combination of which particular enrichment can promote these positive behaviors. So there is a lot of work currently happening in the poultry related research. I looked at the group SETI, the people from, they were giving a talk. It's quite interesting. So this is along these lines. So the idea here is, can we be able to decode the sounds the farm animals make, especially cows, pigs, and chickens, along with natural language processing? So semantics and linguistics based. So we currently use a variety of open AI tools like whisper models, BERT models, and different models to see how do we look at the sentiment behind these vocalizations. For example, we collected a bunch of data, almost 7 different types of data. Avian influenza, healthy chicken. We suddenly opened an umbrella and freaked out the chicken. They ran away. And then we recorded their voice, their movement pattern, suddenly played a loudspeaker without touching the birds to demonstrate external stressors. And then chicken with a group of no stressors. So the different kinds of experiments we conducted and collected a variety of data and acquired vocalization signals. And using natural language processing, we wanted to see, is there any anomaly? Do they express their likes and dislikes? How do they express their sentiments, positive, negative, and neutral? Can we be able to really decode their language in the way we as human beings can understand? So that's a bigger question. It's an ongoing project. So the possibilities of AI in animal farming is humongous. There are many things which we used to think not possible. Now it's possible with the help of AI. But we have to also be very careful in terms of the ethical approach. Are we overusing the technology? Of course, it has a double-edged sword, two sides of the same coin. There are many factors we need to consider. So even data sharing, who owns the data in terms of farmer versus the company that helps to collect the data? That's also a debate currently happening in the sector. Transparency is also a bigger emphasis. So we call this as the HCFAI, Human Computer Farm Animal Interactions. When technology comes in this particular interface, we really have to be careful in evaluating and co-creating, collaborating with a wide variety of researchers and scientists from multiple disciplines to develop solutions to make the technology work for us. So this is my group. Without them, we wouldn't be here anyway. So I want to express my gratitude for all the students and research associates involved in my group. Thank you so much.
Hi, I was just curious about the sentiment analysis for the chickens. So do you start is this like a supervised or unsupervised analysis? Because how, I don't know, for sentiment analysis, if it's like with human text, you would usually have like labels that tell you, what sentiment the sentence is representing. But with chickens, what's your baseline? What's your ground truth really?
So in do chemical analysis, we collect the feathers, do cortisol. So using signal processing, what we call as a future extraction, a male frequency substrate coefficient. So if they are in a positive housing conditions, we see different kinds of futures. And so is the case with the negative and neutral. So the bunch of futures, MFCC futures, are, for example, amplitude, frequency, pitch, the energy behind the sound that would vary for each of those classes. So the futures also vary. That is the difference. It's more like an anomaly assessment rather than having a specific baseline. So it's kind of debatable. We could argue on both sides. Hey, in terms of evolution, comparison to human beings, it's not fully established. But we believe that based on the baseline assessment, the variety of experiments we have conducted, for example, actually the chicks, even before they hatch, inside the eggs, they can make sound. So we put stethoscope on the eggshell and then quantify them. And day 1 to up to 53 weeks, collect data. Continuously, we collect data. And then when we induce external stressors, that also provides a comparative analysis that help us to understand the anomaly between different classes.
Okay. Thank you so much. Thank you so much from the AI for Animals conference.
Thank you. Bye.